Okay, this is part 2 of our review. We're going to go over chapters 10, 13, and 14. So let's start with chapter 10, Consumer Math. And we're going to go to 10.1, percent problems. And so remember that you want to convert percents to decimals and decimals to percents whenever you need it. And so let's start with percents to decimals. So you want to go ahead and divide by 100, or basically move the decimal to left 2 places. Okay. You also want to, if you're going to convert decimal to a percent, you're going to move the decimal 2 places to the right. That's because we're multiplying by 100. Okay. Now, translation method or proportion method for percent problems. I prefer the translation method, and that's what I'm going to use, but I'll show you what the proportion method is as well. The translation method is basically translating a certain amount of words into an equation. So the what, since we don't know what it is, that's an unknown, that's going to be x. Percent is going to be a decimal. Is going to be translated as an equal sign, and of is going to be translated as multiply. That's our translation key. So, for example, what percent of 54 is 23? So you can say, okay, what percent, and that's an x, we don't know what the percentage is, times 54 is 23. Okay? So keep in mind that this x is a percentage. So I like to put a little sticky note here that reminds me that this x, whatever I solve it to be, it's not going to be the answer. I have to still convert it to a percent. So we're going to go ahead and divide this by 54. Basically, you're doing the fraction 23 over 54. So that's going to give us 0.4259. So most people would see the x and say, okay, that's our number, but this is a percentage. So I have my little reminder or sticky note here saying that my x is a percentage, so I have to convert this to a normal x, and that means I need to multiply by 100, and so my final answer is a percentage, 42.59%. You also want to make sure that your answer makes some type of sense. So like, if I would have answered it as 0.42, that is really small. It's almost 0. And so 23 compared to 54 is about half, a little bit less than half. So this one makes more sense, not the 0.4. Next we have another percent problem. 18% of what number is 90? And so we're going to convert this to a decimal. This is times what number's x equals 90. So we just need to divide both sides by 0.18. And we're going to get x equals 500. Now, does this make sense? Well, we're thinking about the number 90. The 90 is 18%. So 90, for it to be a small percentage like that, it's going to have to be over or a part of a big number like 500. So this kind of makes sense. So now, what's the other way to do these two? The proportion method is basically something you might have seen in high school. Is over of equals percent over 100. Okay, where You have the part over the whole in both cases, in both ratios. And then to solve, you have to cross multiply. So some people don't like the cross multiplying aspect of it. So if you don't like that, we can just stick to a one-step equation by dividing on both sides, like in these two cases. Next, we have percent change, and percent change. There's a little formula that I like to use that I came up with. Is basically the new number minus the old number, and then most people struggle with what to divide by. You're always going to compare this to the old number, okay, the previous number, and then convert it to a decimal or a percentage. Sorry. So, for example, you have an SCU team won 30 games in 2015, and then a year later they won less games. They won 22. Okay, so there was a decrease. So we're going to take our new number, which is the 2016 number, and subtract the old number, and then always divide by the old number. So the only way you can get this wrong is if you divide by the new number instead of the old. So just keep in mind, you're always dividing by the old number or the previous number. So that's going to give us negative 8 over 30. And then that gives us negative 0.3636. And so that's not the answer because you got to convert it to a percentage. So we're going to move that decimal to the right 2 places and get negative 36.36%. Now, even though this is the correct answer, in my lab, it's going to have the decrease wording in there. So there was a decrease of, now because it has the word decrease already there, you do not put the negative in the answer because it has already described the negative using the word decrease. So you would just put the positive version of that in here, and then you'll be done. Okay, next we have 10.2 with simple interest. So determine the total repayment of a loan using simple interest. So remember that simple interest is I equals PRT. And if you borrow 3,000 and repay after 9 months with 7.5% interest, what is the repayment amount? So remember that you're not just calculating interest, you're going to calculate interest plus the principal. So repayment is going to equal the principal, what you borrowed, plus the interest, okay? So we know we're going to borrow 3,000. And then how much is the charge for borrowing that for 9 months at this rate? So we're going to calculate the simple interest up here. So 3,000 times, this is 7.5%. So as a decimal form, you move it 2 places to the left, 0.075 times. Now it's only 9 months. This is calculated yearly, so you have to do a partial year, 9 out of 12 months of the year. And then that's going to give us $168.75. So you add that in here, 3,168.75. Next we have 10.3, which is compound interest. So this one's the bigger formula. And so determine the compound interest formula to compute the total amount accumulated and the interest earned. So remember, the A stands for account, your account in the future. So principal times 1 plus the rate divided by the number of compound periods raised to the number of compound periods n times t in years. Okay, so just a few reminders that annual means 1, semi-annual means 2, quarterly means 4, monthly means 12, daily means 365, unless you use the banker's rule, and that's going to be 360. Okay, so you may get any one of those scenarios. Now, so if we have a principal of 3,000, you're going to borrow money for 2 years at 1.8%. That's going to be a 0.018 as a decimal. It's going to be monthly, so it's going to be 12. Now, so my repayment, I'm sorry, look at the wrong one. So so this is going to be A equals 3,000 times 1 plus 0.018, the rate, divided by 12 times 12, raised to the 12th power times 12 times 2 years. So we clean this up a little bit before we type it in. And 0.018 divided by 12 is 0.0015. And we just add that into the 1. 12 times 2 is 24. And now we can put this in our calculator. And like I said, I highly recommend Desmos.com. But you have to have scientific, okay? Okay, once you type that in, you're going to get 3,109.88 cents. That's our account after 2 years with this scenario. Now the interest earned, you can see it right there. But let's just calculate it. Basically, you're going to subtract so 3,109.88 minus 3,000. All right, so the interest earned is $109.88. All right, so now we're going to look at chapter 13, and we're going to start with 13.1. Determining the Euler path. So remember that an Euler path just means that you're going to pass through every edge once. Okay, so you have the theorem on page 814 that's very extensive and really does not apply to the Hamilton paths circuits in the next section. And so the summary of the theorem on page 814, or my summary I should say, is basically how many odd vertices does the graph have. If it has 0, then you have paths and circuits that exist, and basically you can start anywhere, any vertex. if you find that you have two odd vertices, then you only have paths and no circuits, which means you can't come back to where you started. You can only enter in and come out the other side. So you would have to start at one of the odd vertices. Now, if you have three or more odd vertices, then basically there is no path, Euler path, or Euler circuit that exists. So basically, you won't be able to do a graph. Okay, it's not going to be possible. So let's take an example of just a regular triangle. I'm going to draw a line in the middle and label this A, B, C, D. And we analyze our vertices and see if they're even or odd. So A has two edges connecting to it, so that's a 2. B has 3, C has 2, and D has 3 as well. And so you can see we have two odd vertices here, which means that we do have a path, an Euler path, but we don't have a circuit, and we can start at either B or D. Okay, so if I start at B, I can go to C, and then to D, and then to A, and then back to B. I'm sorry. B, C, D, B, C, D, then B, and then A, and then D. Okay, sorry about that. Or we can start at D, since it's another odd vertice, and I can go to the left A, and then go up to B, down to C, and then left to D, and then up back to B again. 13.2 was the Euler circuit. Basically, that is beginning and ending at the same vertex, but passing through every edge once. So let's do another triangle, but this time I'm going to draw another triangle inside, upside down. And now I can label this A, B, C, D, E, and F. So we analyze our vertices and say, hey, this is there's two edges connecting to that one. There's 4 here. There's 2 here. There's 4 here again. There's 2 here, and there are 4 edges connecting to F. So as you can see, those are all even, which means we do not have any odd vertices. Okay, that means we can do a path, we can do a circuit, and we can start pretty much anywhere. So let's go ahead and do that. We can do, we can start at A if we want, B, C, to D, and then to E, and then we're going to do F, then we're going to go up to D, then to B, back to F, and then to A. Okay, so make sure if this is a multiple choice question that you're choosing an option that begins and ends in the same vertex, because this is a circuit. Now let's take a look at 13.3 with Hamilton paths. So you're going to pass through every vertex this time once. And so because we're focusing on vertices, it's like a location, and we're not worried about edges, then we cannot use Euler's theorem. Euler's theorem is very restrictive on if you can make a path or not. But with Hamilton, since you're concerned with vertices, then it really doesn't matter You can make all kinds of different possibilities with Hamilton. Okay, just focusing on the vertices. So A, B, C, D, and then E. Okay, so we can just start at A and then go to B and then go to C and then go to D and then go to E, and that's it. Or you can go from, instead of going to B, we can go to D, then we can go to E, and then we can go to C, and then to B. Okay? So many different possibilities with Hamilton's paths and circuits. So our last topic is 13.4, the tree diagram to model relationships. So I'm going to leave this blank for you to fill out when you submit this to me. I want to see your own family tree. Okay, so have some fun with this, get creative, and try to think about your own family. Okay, last of all, we have chapter 14, voting theory. So we're going to do 14.1, 14.3, and then the flaws. So in 14.1, remember that those 4 different ways you can determine the winner of an election. In this case, we're just going to focus on the plurality method, okay, which seems to be confused with the plurality with elimination. All right, so we're just going to do plurality method. Remember, it's just the most first place votes, and the majority. To achieve the majority, you have to have greater than 50%, okay, of the votes. Now, so here's an example election, and we have 3 candidates, S, J, and C, and here are the preference tables. So at first glance, it looks like S won because S has 10. But J has 7 and another 4, so that would be 11, making J the winner. Okay. Now, did J have a majority? So remember, the majority is more than 50% of the votes. So, did J have more than 50%? Well, we need the totals, so the totals are going to be here. And if you add this up, you get 29. And so half, or 50% of 29 would be 14.5. So we need 15 votes to have a majority, and we do not have it. Okay, so J wins. He has 11, but not with a majority. Okay, and that sometimes can be very important to people. And that's why, if that is important to a certain group doing this, then you would have to hold another round, round 2, which means you have to eliminate the C, because he has only 8, he or she has an 8, and then you would have to add those to S, and then you would have a majority. So it just depends on the situation and the group and what's important to them. So 14.3 is apportionment, and we're going to focus on Hamilton. So there is a procedure you have to follow. So first of all, here are your 4 steps. Remember the formulas for the standard divisor would be to take the total population and divide it by the number of items to be allocated. Now, then you want to find the group standard quota. So you're going to take the group's numbers. Each individual group's number, and then divide it by the standard divisor. Okay, and then you're going to do round each group standard quota down. Okay, and then you're going to distribute any leftover items to the groups or group with the largest fractional parts. Okay, so let's take each one of those. So for example, we have a resort company that bought 50 new beach umbrellas, and they want to send those out to their resorts, and they're not going to do it evenly because some resorts have more demand, and as you can see by the size here, they're doing it by number of rooms. Okay, so step 1 would be to take the total. So total number of the total population of 600 rooms divided by the 50. So 600 rooms divided by the 50 umbrellas, and then that gives us 12. Then we want to take our standard divisor, which is 12, and divide it in each of the groups. So each resort we're going to divide by 12, and that's going to give us 8.17, 9.5, 11.92, and 20.42. Okay. Third step is to round down. So we're going to just take out each of the fractional parts, the decimals. So it's just going to be 8, 9, 11, and 20. Now hopefully this adds up to 50 umbrellas, but let's see. So adding these up, we're going to get 48 umbrellas. And that means out of 50 we have 2 left over. So we got to decide who's going to get, or which resort is going to get these leftovers. So Hamilton said, okay, just give it to the highest fractional parts. So we can see we have a 0.92 and a 0.5 right there, which means our final numbers. Okay, this is going to stay the same. This one's going to get an extra, so he's going to get 10. Resort B. Resort C is going to get an extra umbrella, so they're going to get 12. And this one stays the same. So now we have our 50 umbrellas allocated. And that makes sense because we have the biggest resort getting the most, 20, and the smallest resort getting the least, which would be 8. All right. And that is it for chapter 14.3, let's go to our last section, which is the vocabulary. So for 14.2 and 14.4, the vocabulary, the flaws, this is just to get you familiar with the fact that there are no perfect systems for voting or for apportionment. Okay, each one of these has a flaw, and so you just need to know and pretty much use this handout as you take your test as notes to pick, to match it up to the correct flaw for voting, which is majority criterion, head-to-head criterion, monotonicity criterion, and irrelevant alternatives criterion. Okay, just match it up. And then for the apportionment flaws, you have the quota rule right here, the Alabama paradox, the population paradox, and the new states paradox. Okay. And so again, the main idea for this vocabulary is to show you that there is no perfect voting method and there's no perfect apportionment method. All right. And that is it for the review. Make sure you have this filled out either through, so you can print out, you can type it up or mark it up digitally. Or you can just write on a separate sheet of paper, okay? Whichever one is easier for you. And then make sure it's all filled out, including your family tree, and then email it to me, okay? Oops. Okay, so if you have any questions, please let me know. Send me an email, send me a text, call me, whatever you need to do, okay? Talk to you soon. Hope you guys do an amazing job in your final exam.